Hi everyone, just a quick video showing you solutions for the test that you've done recently. I hope it went well, but if it didn't, well, let's have a look. Doesn't matter. The real thing's what counts, so let's try and do it. Okay, first thing first, use a binomial expansion to expand this. Sorry about the formatting as well, it's just from LibreOffice. But okay, so we've got to expand this. Now, first thoughts in my head are this isn't a 1. We need that to be a 1 in order for us to employ the formula. I haven't got the formula book here, but I'll just write down what the general result is. It's 1 plus x to the n, or as I like to call it, 1 plus stuff to the n, equals 1 plus n times stuff plus n times n minus 1 stuff squared over 2 factorial. And how many terms are we going? Up to x cubed. So plus n times n minus 1 times n minus 2 x cubed over 3 factorial. Easier to just call that n choose 2 and n choose 3 actually, but there we go. Okay, so we can't do that yet because we've got to fiddle around with it. Whenever that's not a 1, doesn't matter what this can be any old stuff, so I can just replace x with minus 4x, but that must be a 1. So I better fix that too first. So take it out carefully, and the way we take it out carefully is we say, okay, 2 times 1 minus 2x would be 2 minus 4x, and that is all going to the power of minus 2. And then because we've got a product here, because you've got a times b to the n, where a is 2 and your b is this bracket here, well, that's a to the n times b to the n, isn't it? From like rules of how you manipulate indices. And so what I can now do is write 2 to the power of minus 2, which is a quarter, times by 1 minus 2x to the minus 2. And now I can get started, yeah? So I'm going to just have, okay, this equals a quarter times by, okay, 1 plus n times by, now my x is minus 2x, yeah, plus n times by n minus 1 times by minus 2x all squared over 2 factorial, which I'll just write as 2, plus n times n minus 1. Please do that in your head as well. I hate seeing minus 2 minus 1 in brackets. Like, just do take away 2, take away 1 in your head. Like, you'll always get nice patterns here anyway. So n minus 1 n minus 2 minus 2x all cubed. And I'm going to call this 6, and I might even straight away cross that out with that because they're going to cancel, aren't they? Dot, dot, dot. Okay, leave the quarter alone for the moment. Tidy this up first. 1 plus 4x plus, okay, cross that out. Do this easily. 4x squared times by minus 3. That is actually going to be a minus, this one. 4x squared times minus 3 is minus 12x squared. And then what have we got here? We're going to have minus 8, but times by a minus, so it is going to be a plus 8 times 4, which is 32x cubed. And then at the end, dot, 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 that equals a quarter, might as well times it through, plus x minus 3x squared plus 8x cubed, and that completes it. Now, always check at the end for any mistakes. I think I've just spotted one here. That minus is going to cancel with that minus, and so that is actually going to be a plus. It's normal to make mistakes when you do a binomial expansion, especially with the sign. I just made one there. That was a genuine mistake, and I looked up and thought, no, hang on. So yeah, watch out for mistakes. You can, if you want to detect mistakes as well, remember that this is supposed to be a really good approximation, especially when x is really, really small. So what you could do is see how good your approximation is to a number. I mean, it'd still be hard to detect, but it's a possible way of sort of checking. But probably the best thing to do is just read through your lines again and try and spot any errors. But I think that's right now. Okay, right. Part B. In the binomial expansion of f of x in ascending powers of x, the coefficient of x is 0 and the coefficient of x squared is 12. Now this is a new function. It's been the last one after it's been multiplied by a plus bx. So all I'm going to do first is I'm going to say f of x equals a plus bx. A plus bx times that, a quarter plus x plus 3x squared plus 8x cubed. That's what f of x really is. It's a plus bx times that. Now, it's told me that the coefficient of x is 0 and the coefficient of x squared is 12. That gives me enough to find my value of a and b, because if I times this, do this systematically, times it all by a first, then times it all by bx. So we get a over 4 plus ax plus 3ax squared plus 8ax cubed. And then we're going to times it all by bx. So we get plus bx over 4 plus bx squared over 8. Bx squared over 8. Did I get that right? Or just bx squared, I think. Dear oh dear. You see, I always make mistakes when I'm doing maths. It's normal. Plus bx squared on its own, and then plus 3bx cubed. And you know what? I think I'm going to stop there. I could do the next one, but all I actually care about is the coefficient of x and the coefficient of x squared. So I didn't even need to do all of that, but sometimes you just want to get used to the pattern. Now, coefficients of x are here and here. Coefficients of x squared are here and here. Find the ones which are relevant to you. Okay, so we've found those. What can we say about that? Well, we can say that ax plus bx over 4 is supposed to be equal to, if you like, 0x, because coefficient of x is 0. You can now cross out the x's, times by 4, you get 4a plus b is 0. Yep, that's right. This question's really a simultaneous equation. We've also got 3a plus b. Do you mind if I just ignore the x squareds this time? 3a plus b is 12, equals 12. And so I've got two simultaneous equations to solve. Now, if I subtract them, I should be able to find a, because they've both got a b on the end. Ooh. So let's subtract. We're going to get a is minus 12. Watch out for the sign error there. And if a is minus 12, b is going to be 48. And there we go. We've done it. Part C, find the coefficient of x cubed, giving your answer as a simplified fraction. Well, that's handy because we've actually done that. I didn't know this was coming. I genuinely haven't worked through this yet. What have we got here? We've got 8a x cubed plus b, 3b x cubed. So we're just going to have to chuck in our a's and b's here. So we're going to get 8 times minus 12, which is minus 96 x cubed. And then we're going to get 3 times 48, which is 144 x cubed. If we simplify those, we're going to get, what is that, 48 x cubed. And so the answer is 48. Done. Okay, what we got next? Do sine x minus 3 cos x. Got to write it in form r sine x minus alpha, giving alpha in radians. Okay, so bear that in mind, calculators in radians and all that. Right, sine x minus 3 cos x, we're going to write as r sine x minus alpha. But then the first thing I'm going to do is I'm going to write the left-hand side out again, just so you can see where I'm coming from here. R sine x cos alpha minus r cos x sine alpha. What am I using there? I'm using the compound angle formula that says sine of a minus b, and it's in the formula book, is sine a cos b minus cos a sine b. And then I'm timesing it all by r. But that's what I'm using there. Okay, now I can see that and this is called equating coefficients, that r cos alpha must equal 1. And I can also see that my r sine alpha, oh look, I've made a mistake there, I'm making loads of mistakes today. This should be sine x cos x sine alpha. Dear oh dear. Oh, got the wrong pen. And so I can see now, if I underline this, that not minus 3 here, because there's already a minus there, but 3 equals r sine alpha. Now I can get tan alpha, which means, it's going to be sine over cos, so tan alpha is 3. R is always 1 squared plus 3 squared here because, well, if you like, r squared sine squared alpha plus r squared cos squared alpha is just going to be equal to r squared, isn't it? Because sine squared plus cos squared is 1. But yeah, that's one way of looking at it. There's loads of ways of looking at it. You could also look at it like alpha's here. This is 1, this is 3, and this is r because, you can see that because sine alpha is opposite divided by hypotenuse, etc., etc. Okay, so we get tan alpha is 3, so we can invert that. And I think inverse tan of 3 in radians is 1.25. And then I can find r by just doing 1 squared plus 3 squared square rooted. And that's root 10. And so I'm going to write it as sine x minus 3 cos x. Do write down the answer at the end is root 10 sine x minus 1.25. Remember, that's something you definitely can check, because all you've got to do to check it is just plug in any number you like for x, yeah, and do it on a calculator. See if that, let's say pick x is 2, sine 2 minus 3 cos 2, yeah. Now plug 2 into this and make sure you get the same number, because it should be an identity. Okay, hence write down the minimum value of sine x minus 3 cos x. Well, we can see it's the same as root 10 sine of stuff, yeah. Now sine of stuff has a max value of 1 and a min value of minus 1. Root 10 sine of stuff has a max value of root 10 and a min value of minus root 10. It's just a stretch in the y direction, so it's no longer between 1 and minus 1, it's now between root 10 and minus root 10. So the minimum value is minus root 10. Done. Okay, find the value of x in the interval 0 to 2 pi at which this minimum value occurs. Well, sine normally gets to a minimum in radians at, what is that? That's pi over 2, that's pi, that's 3 pi over 2, yeah? In other words, you want your stuff to be 3 pi over 2. So x minus 1.25 is 3 pi over 2, and x is 3 pi over 2 plus 1.25, which is 5.96. Now, can I point out, if you did just set this whole thing equal to minus root 10, that would also work, but you're just going to do a couple of extra steps. Okay, that was 2. 3, let's do 3. Show that sine 2 theta over 1 plus cos 2 theta is tan theta. Let's do it. Okay, if we do left-hand side, yeah, that looks more complicated. We've got sine 2 theta over 1 plus cos 2 theta. Straight away I'm thinking, these are two double angles. That's a single angle on the right-hand side, so I must convert to single angles. So let's use double angle formulae to go from the doubles to the singles. 2 sine theta cos theta is sine 2 theta. Learn that one. With cos 2 theta, you've got a choice. Now, you know, who knows what we're going to do? Like, you can do it with any of them, I promise you that. But remember, cos 2 theta equals like 2 cos squared theta minus 1. Yeah, that's one of them. It also equals cos squared minus sine squared. And it also equals 1 minus 2 sine squared. You can use any of these, but this one seems quickest to me because I'm going to get rid of the 1 plus, because I'm then going to do take away 1. And that kind of is an advantage because the bottom is then just one term. It's not two separate terms. So I can cancel the 2 and the cos theta and get tan theta, which is the right-hand side. Can I point out, in the exam, they sometimes don't give you full marks if you write what I've just written down there. I suggest that you justify your stages by actually writing down the formulas you're using. Sine 2 theta is 2 sine theta cos theta. I've used that one there, and I've also used sine cos 2 theta is 2 cos squared theta minus 1. I know I wrote it up there, but I'm emphasizing here. Write it down in a little bubble next to where you've done the working. Here, point out to them that you do know that sine theta over cos theta is tan theta, because that's the identity you've assumed true there. And at least then I suppose we're signposting to the examiner what we're using. Okay, what we got next? We've got hence solve this, a very typical thing. Now what's happened going from here to here? We've times it by 3. We've times it by 3. So this is really just saying 3 tan theta equals 1. So tan theta is a third. And we're just going to solve it like that. Now, if tan theta is a third, you get theta is 18.4. And rule of thumb for tan is 180 plus. But that takes us out of the range. So there's no point in writing down that one. But you can add or subtract 180s with tan. And so the other solution in that range, anyway, is minus 161.6. With tan, you can always add a 180, another 180, another 180, another 180, or you can take away a 180, take away 180, take away 180. That's because tan repeats every 180. That's exactly what it does. Its periodicity is 180 degrees. The length of, like, you know, from the start to the finish. I think of it like wallpaper. The width of the wallpaper is 180 degrees. Okay, consider the curve with equation x squared plus xy plus y squared is 243. This looks like implicit differentiation. Straight away I'm thinking probably implicit differentiation. Sure enough, they've asked for the gradient, and so we're going to have to differentiate it. Now, when you implicitly differentiate, the rule is with x's, you just differentiate them normally. Yeah, so x squared, that's no problem. Let me deal with xy in a second. With y squared, we have to differentiate it normally, but if you ever differentiate a function of y, The rule is stick a dy by dx on the end. If you understand nothing else about implicit differentiation, understand that, because that will get you, even if you don't understand why you're doing it, that will get you towards the right answer. If you want to know why you're doing it, it's because we're really doing d by dx to everything. And if you do want to do d by dx to a function of y, well, tough. You can't do that. You can only do d by dy to a function of y. So instead, what we do is we do d by dy to a function of y. But because of the way these things work, if I times it by dy by dx at the end, the dy's would cancel and it would be equal to the line above. And that's why when differentiating a function of x, when differentiating a function of y with respect to x, you just differentiate with respect to y and stick a dy by dx on the end. That's what you do. 2, 4, 3 differentiates to 0. Now, the hardest bit, xy. Why is it hard? Because it's a product, and people forget that it's a product. So you have to differentiate one side of the product. Now, we differentiated x there, so that's just 1. But product rule says we have to times by the other side undifferentiated. Now, we didn't differentiate y there, so we don't need to stick any dy by dx's on it. But now we're going to do it the other way round. And if I differentiate y, well, differentiating y gives me 1. Now times it by dy by dx, I get dy by dx. And actually, that's obvious. Y, of course, should differentiate to dy by dx. We've been doing that for years. But then times it by the other side undifferentiated, and you get x dy by dx. And it's done. Now, we've differentiated it, but we've got to find, in terms of k, the gradient at minus 9k. Now, my first thought is, I actually can find k, because I've got the x-coordinate here, 81, minus 9y plus y squared is 243. So I'm thinking straight away, oh, well, they want me to find it in terms of k, though. Oh, right, yeah, maybe that comes in a bit. I just suddenly thought, well, why don't I find that k? But they want this in terms of k, so actually there's little use in finding that value of k, I think, at the moment. So, yeah, sorry, let me just continue as I was down here. I do this a lot in maths. I kind of like go in one direction and go in another. I'm going to take these two terms on the other side, and now I'm going to divide it. It almost looks like it should cancel there, but it doesn't. And now they want to know the gradient in terms of k at this point. So I'm just going to plug in this point. So I'm going to get 18, because minus 9 times minus 2 is 18, minus k, over minus 9 plus 2k. And that is it. That's all you've got to do. So that's kind of nice. Okay, next one. Given that the tangent to the curve is parallel to the x-axis at this point, parallel to the x-axis. Now, when a line is parallel to the x-axis, what's its gradient? Yeah, 0. All of these lines have a gradient of 0. The gradient is always 0 if a line is flat. And so this is just their way of disguising saying the gradient is 0. So we need to set this equal to 0. Now, if you've ever got a fraction equal to 0, there's really good news, because you can times the denominator over, and therefore you get just the numerator equals 0. And that means k is 18, and you're done. I was very tempted there, just because I thought, surely if I'm given my x is minus 9 here, I can find the y coordinate there. I guess the y coordinate is going to end up being 18, but they've given me a quicker way of finding that answer there, where I can just do it in one line. So there we go. Okay, that's the first 4 questions. I hope it was useful, and yeah, I will do the next 4 right now.